Hey guys, welcome to Concept and Coding, and this is Shreyansh, and today we are going to do the next topic of Spring Boot, that is Maven. Right, this is, you can say that, the most underestimated topic. We generally think it's just mostly Maven do build generation, nothing much more than that. But today I will show you what all things Maven can do, why it is very important to know about Maven, and how it makes our developer life easy. Okay, so let's start with the newest topic in Spring Boot, that is Maven. So Maven is a project management tool, not just build management tool or build generation tool. No, it's a project management tool which helps developer with build generation. So it's just a one part of it, right? Also dependency resolution, documentation, and there are lot many other functionality which Mavens provide. Okay, so Maven uses POM, project object model, to achieve this. So whenever we give Maven command, right, let's say Maven install Maven, you can say that there are another command like deploy. We will go through this commands, but whenever what I'm trying to say, whenever we give this commands to Maven, what Maven first do is it look for pom.xml in the current directory. From the directory currently you are running this command, so it looks for pom.xml and then try to look for the configuration what it has to do with this. Okay, so Maven is highly dependent, you can say that, pom.xml. Okay, so if you remember, before Maven there is something called ant, which was very popular. Okay, so in the ant we have to tell generally what to do and how to do. In Maven generally we have to only tell what to do, how to do, that's now Maven is taking care of. Maven knows that, okay, you only tell me what to do, how to do, I will take care of it. For example, we have given this command Maven install, for example. Now we tell Maven what to do. Okay, you have to install. How? I haven't tell. Now that Maven will take care of it. What? Okay, you have tell me what you have to do. Now how to do it, that Maven will achieve. In Ant, we have to tell what to do and also how to do it. We have to provide the sequence of steps to achieve what we have to do. Okay, so advantage of it is Maven is that it simplifies the developer with various tasks like build generation, dependency resolution, documentation, and lot more things. And also it only we have to provide what to do to it, right? What task we have to do, how, that Mavens take care of it. Okay, clear? Like, what's the advantage Mavens provide, why Maven exists, right? So if you remember, this is the Maven project structure which it follows. Okay, and if you remember in the previous video where we have downloaded or set up the Spring Boot project and we have selected the Maven. So this project got downloaded, right, with one class Spring Boot application in this package. Learning Spring Boot, this is our the app name which we give, and source main Java, and this is what we provided into the group ID artifact, if you remember. So this is the package how the Maven follows, and there would be one pom.xml. So this is what generally Maven project structure is. So whatever your app name is, it will first create its directory. Then in the main directory itself, you will have pom. Okay. Then there you have source, main, Java. Okay. So source, main, Java, and there you provided in the Spring Boot, we have provided this three, right? So it create a package like this, concept and coding, learning Spring Boot. These three things we have provided while creating a Spring Boot project, if you remember. And this is one Java application class it will create like this. Okay. And here if you see in the source parallel, you will find one package of test and then the same Java com and the same name, the same project structure and its equivalent test class, right? So this is generally unit test cases where we will write in this class. For this Java class, we will write unit test cases in this. Okay. So here if you see that we have source, they have test in parallel, the same Java com concept coding, learning Spring Boot and Spring Boot application test. Okay. So this is the project structure for Maven, which generally follows, and that's why you see this kind of structure when we downloaded the project from the Spring Boot using Maven. If you have selected Gradle, might be some other structure got downloaded which Gradle supports. But for Maven, this is the project structure which Maven supports. Okay, now when the project got downloaded, right? So this pom.xml we got, right? So the same pom.xml I have copied here and I will show you what exactly it is, like how to read this pom.xml, what generally the meaning of each properties and elements defined here. Okay. So here if you see the first part, this project. Okay, this first part. What here you will see certain kind of schema location. Okay, so what does it? It specify the XML schema. Also make sure that our XML adhere to the correct structure and version defined by the Maven. So whatever the XML, you can say that the rules it has provided in this schema, this should be the name. Okay, inside this parent you can have group ID, artifact, version only. You can't by default use that, hey, can I write this here something XYZ close. Can I do something? No, it is this XYZ is not defined in the schema of the parent inside this. So we can't write something like randomly. It has to follow properly what within this element, what all things can we write, right? So it should follow certain schema. Here if you see the parent part, this one, this is used to define the parent project. The project, if you remember, which we have downloaded from Spring Boot, right? So the POM which we got, so in the POM you will see this parent block, means this is the child POM. Child POM of what? It's a child POM of this. So in Maven, each POM.xml is a child of some other POM, right? If you have defined this, so currently it's a child of this project POM. So whatever this project, so these are, you know that group ID and artifact ID uniquely identify a particular project in the Maven Central. Okay, so in this project, this is the version, there would be some pom.xml, so that would be parent of this POM. Parent. Okay, so each POM has one parent. If there is no parent defined in the POM, let's say that if there is no parent defined in the POM, then Maven automatically by default make inherited from a super POM. So in Maven, every POM which you are writing, right, internally by default it's a child of super pom.xml. Okay, so generally in our case, in our POM, the pom.xml which got downloaded in our project, this one which got downloaded with the project, it is given that it's a child of this project. So Spring Boot starter parent, Spring Boot some starter parent project, it's pom.xml. So this is its parent, and this itself might be a child of super pom.xml. Okay, so you got it. So this, there could be some other parent for this one, or if no, then it ultimately would be a child of this. So we can, in simple terms, we can say that super POM is something which is at the top of the hierarchy. Now whatever the POM you will create, whether this or this, generally it's a child of this super POM only. Okay, so the parent used to define the parent project. Current project inherit the configuration from a specified parent project. So our project is inherited the configurations from here. So in our pom.xml, if you see, this is very small pom, right? There is not much configuration. Why? Because it might be using the configuration from its parent. In its parent, it might have provided lot of configurations, right? So since it's a child of it, it will use its configuration, whatever its dependencies, all the dependency which this parent has, or the configuration which parent has, all will automatically comes to your child also. So if this parent field is not specified, Maven by default inherit the configuration from superpom. So this is the link of the Maven superpom I have provided. Okay, so you can check out the superpom.html here. There are a lot of configurations, by default configurations are available, which generally comes to your project, this configuration and dependencies. Okay, so you understood what is the meaning of this parent. Means our project is generally a child of this project actually. This three parts I have already informed you, right, in the previous when we created this Spring Boot project. Group ID, artifact ID, version. These three uniquely identify our project which we are creating. So this is the company name, generally you can say. This is your ultimately the project name, and this is the version currently. So this uniquely identified your project in the Maven Central. Okay. Then we have something called properties. So what is property is? It's a key value pair for configuration, right? So this is a key, this is a value. Okay, so it can be referenced throughout the XML file. So now in all other XML file, I can use this property, this key. How? Let's say in this dependency, group ID, artifact ID, and let's say I want to use certain version. I can use like that, that's let's say a version. I can do like this, $ this java.version, java.version, close. So now this $java.version, ultimately what Maven will do, it will check in the properties. Hey, for this key, is there any value defined? Yes, 17 is defined. So this will get ultimately with replaced with 17. Okay. So anything which you define in properties, it's generally a key value, and then this key can be referenced anywhere in this POM. Okay. Okay, now let's see the next property, which is like repositories. So what does it do? This is from Maven. Look for project dependency and download the artifact jars. So here if you see that in this repository, we have defined it one URL. Okay. So what this URL is, this is the like URL from where you want to download your dependencies. So this is the next, if you see, we have a list of dependencies. First is this. This is our first dependency. Then this is our second dependency. Now from where this dependency will get resolved? From this. Okay. So this is from where Maven look for project dependency and download the jars, right? So this is generally, you can say that I have written it for you, but here if you see in the project which is downloaded, you will find that this is missing. This is not there. This is not there. Generally, this is added. This is a by default which Maven added. You can say that maybe in the superpom.xml you might find that this is by default value is present. If you don't add it from its parent pom, this will get added. So by default, it will always download from Maven Central only. By default. So even if you don't write this, maybe if you go and check in superpom, you will find this. So that's why it is not required to add it here. And even in the pom.xml which you downloaded, if you double check, you won't find it, because I have added just to show you that from where it downloaded the dependency. So till dependency is all clear, right? Now actual Maven starts when you see the build, this build element. And before I tell you about this build, you first need to understand the build lifecycle. Then only you would be able to understand why we have to provide this build. What is the usage? Deep dive into this, but first let's understand the build lifecycle. So below is the Maven build lifecycle. So let's say that first is validate. So this first phase is validate phase. What is the second phase? Second phase is compile. We will see each phase in depth, but I'm telling you that these are the sequence. First phase, second phase, third phase is what? Test. Okay, so first it will validate the project structure. Second, it will compile the source code. In the third phase, it will do the testing. Means it run the test cases. In the fourth phase, what it will do? It will package. Means it will package the compile code into this jar. Fifth phase is verify. It will verify the integrity of this package. Sixth phase is install the package into local repository. And the final and the seventh phase is deploy, where it will deploy the package into the remote repository. So we will see each 7 phases in depth, and then after that you can say that yes, you are clear with Maven. But one thing you have to say that these all are sequential steps. Let's say that if you want to run package phase, which one is the package phase? Fourth phase. Then all its previous phase will also get executed first. So now let's say if you say that, hey, I only want to run this phase. When you give the command to run this phase only, then all its previous phase first will get completed. This will get completed first. This will get completed first. This will get completed first, and then only this will run. Okay. So there are, you can say that sequential. So there are different phases, right? So these are all phases, and each phases has goals, multiple goals, goals 1, goal 2, there can be different goals. So first phase can have multiple goals. Second phase can have multiple goals. So consider goal as nothing but a task. In first phase, validate phase, there can be multiple tasks. Second phase is your compile phase. There can be 2 or 3 tasks which it might be doing, right? So that's what I have written here. If you want to run a specific task of a particular phase, for example, again, let's say for the package, inside a package, there are, let's say, goal 1, goal 2, goal 5. Let's say there are multiple goals. In the package, this is your phase 4. Now let's say that, hey, I want to execute this goal, and there could be more goal, let's say. So this is nothing but a task which is happening in this phase. Okay. So you want to perform this task. So to perform this task, first it will goes in sequence. It will perform all the tasks of this phase all the tasks, all the goals of this phase, all the tasks of this phase, and in the fourth phase it will perform all the its previous tasks, this task and till this task. So got it? If you want to do any particular task, if you want to run a particular task, then all its previous phases and their tasks will also get completed. If you want to add a specific task in a specific phase, Maven provides the functionality or flexibility to add it. Let's say that, for example, in this install, in the sixth phase, what is the sixth phase is install. There are three tasks, task 1, task 2, task 3. In the sixth phase of install, this is the phase, there are, let's say, 3 tasks. Now you want that, hey, I want to add another task 4 in this phase, in the install phase. How you can do it? Through build. Okay, so this build element help you to add a new task inside one of this phase. So this is the validate. First phase is your validate. What validate does is it validates the project structure. Okay, so here if you see that Maven already has this validate phase and it is executing its task. But if we want to add more tasks, then we can use build element and add the goal to a specific phase. So now what is the command to run the validate? Maven validate. So now here if you see what I am doing here, I am adding a new plugin. This would be inside build. Build, close, like this. Inside this build, we are writing a plugins, right? Plugins and then writing a plugin. So I'm writing a new task here. So this is the group ID, this is the artifact ID. This Maven already support plugin, right? Maven has so many plugins. You can either create your own task or you can already Maven which supports. You can whatever the Maven support, you can add it based upon your project need. So this is one plugin which Maven supports. So in this, these are the coordinates where it will go and download what task it is. Now here if you see in the execution, this is the task. Okay, and here if you see this task is added to which phase? Validate phase. Okay, so Maven already has this default phases. Each phases already has defined goals, which Maven by default has it, what it has to do. But if you have a requirement to add more tasks, this is how you can do. And you can also provide the configuration. If any configuration requirement is to read, it will read this. So what ultimately doing is this plugin, right? What actually does it? It do the check style. It will validate your check style. For example, my code style.xml, there should be like a space between that. Certain a code check style. So it will validate that your code is following a particular check style or not. Every company has different code style. Some follows this, some follows this, right? So they want to have a different structure. So you can use that. So you can enforce it here in the validate phase itself. Before compiling itself, it will first validate. So you got it? The second is compilation of source code. You already know what compilation will do. Okay. So it will convert your Java code to bytecode .class files. Okay. So we have to run the command maven compile. And when we run the maven compile, you know that it is following a sequence. So even though we are running this command maven compile, directly this phase, But first it will also complete the validate phase also. So it will validate and compile your code and put it under target classes. We'll show you. So now let's say I have run this command Maven compile. So this is the project, right? On the same project, if I run Maven compile, then this project, what it will do is, so here if you see, this is the phase it is running. You won't find validate phase. You won't find validate phase because I told you Maven doesn't validate anything. Like it doesn't restrict you. Whatever, how you want to write a code, you can write it. But in case you want, you can add this plugin. Like you can go through and check different plugins and you can add for validate. But here if you see when you do Maven compile, so this phase runs and what it does is it internally do Java C. Now you understand this. I haven't tell Maven that do Java C something. I just told him compile, Maven compile. I told him what to do, how to do, I didn't tell it. But internally it has this plugins, right? So what it will do is when this command goes, right, Maven compile. So what it will do is Maven will look for pom.xml and it look for this Maven something called compile plugin. In our pom it's not there, but might be in super pom it would be there. So in super pom it would be having certain coordinates, group ID, artifact ID, version. So Maven will use that and fetch whatever the details it has to fetch. So there Maven has already provided internally Maven has already all the details how to compile the code. Whether through Java C or is there any other way, it's their header. We don't know, right? But internally it uses Java C and it moves the classes to this target. So here if you see, this is our project, source main Java. This is our package. This is the classes which we wrote, and here, and after Maven compile, you will see new folder comes into the picture. After this test, there's something called target comes in. Inside target classes, and if you see that there are all the dot classes files comes in. So these are the bytecode for this. So you got it? So this is I was saying. So previously Ant was popular. There we have to tell what to do and how to do. So this is just one example of how we used to do. Like in 2015-16, like we have to say that okay, compile. This is the project, and we have to do compile. Where this is the destination directory where you have to put the compile code. And we also put that you have to do this Java C. Okay, so here if you see that we are providing it that okay, you have to compile. So what? And here we provide the command also Java C, how. So what and how, what both we provided to the Ant. So read all the files within this folder, put it here. How? This. But in Maven, this is abstracted now. Only we tell them Maven compile, and now all this logic is now abstracted within Maven code base. You can say that in Maven Central, it might have certain plugins. So it's like a plug and play. That plugin you just plug in your POM and it will work. Okay, so third one is test. So when you know that what is the command Maven test. So now when we run this Maven test, you know that first it will run validate, second it will run compile, and then only it will run test. So it will validate, compile, and then run the test cases in your project. So this is our project, right? This is the class, and let's say this is the test class, which is inside a test package. I have already told you this is the structure of Maven. Inside this test class, let's say I have written one unit test cases. This is unit test cases. I have just simply written system.out.println concept encoding test case running. Now I am running Maven test. So it will do first validate. Validate generally Maven doesn't do anything, and we also haven't added anything. Then second it will do compile. It did the compiling. And the third it is running the test. So in compilation it didn't do anything because nothing to compile, because already everything is compiled, because I have just done the compilation. So already everything is compiled. So that's why it didn't compile. So that's why it says that nothing to compile. All classes are up to date. But here it follows the sequence. First it goes to the compile and then only it comes to the test, and then it run all the tests, all the test cases, unit test cases inside this folder. And here if you see that concept encoding test case running, it should get printing over here somewhere. Yeah, concept encoding test case running, it got printed. Build success. Okay, so this phase is clear. The next phase is package. The command is Maven package. Now you know we are trying to run this phase. This phase, when it runs, it has to run its previous phases also. What it will do, whatever the compile code which we got, right, it will create a jar out of it. First complete validate, compile, then test phase, and then run the package phase, in which it generates a .jar file or .var file, whichever you have selected. We have selected .jar in our springboot. So when I run Maven package command, so validate is nothing. So this is, then it do compile phase, then test phase. This is the test phase is running, and test cases ran, and after the test cases it will do the jar phase. This is your fourth. And if you see that where it put the jar into, so it's building the jar into this target here. So earlier this is our package, right, after compilation and all. So after Maven package, in the target itself you will see this jar get constructed. Right now this jar you can share with someone, they can add it as a dependency, you can deploy it, right? So this now has everything, it's packed, everything whatever is required for our project to run. Okay, it has bundled of everything. So you got it. Maven package, what it does, it creates a jar and put into under this target folder. Okay, after that package, what is the fifth phase? Fifth phase is verify. Maven verify. So generally also here Maven doesn't force you to verify anything. So might be currently I don't think there is any task present here, but we can add it, right? So let's say I want to add one verify phase, that I want to check the integrity of the package. Like, so I want to do static code analysis. A static code analysis checks apart from unit test cases. A static code analysis means like if the code has some unused variable, unused import, empty catch block, no usage of object, duplicate code. I want to find all these things and report it as a warning or might be something, right? So I can add a plugin which does all this thing. So I can add it in the verify phase. So here if you see that I am adding a new plugin. So I provided the coordinate to the Maven. Hey, this is the PMD. So PMD has provided all this functionality. PMD tool can do all these things. So this is the coordinate where this PMD we can download the dependency, right? And in this PMD, this is the goal. This is the task we wanted to do, right? Out of this plugin, there might be multiple goals or multiple tasks. I want only this PMD task. So this PMD task does all these things. And I want to put it into which phase? Verify phase. Okay, so how it does this, we don't know. Some company or some developer have built this and deployed it into the Maven, and it's open source, we can use it. Now we are using this in our code base. This is way. So we can provide it coordinate. The task name which they have given, we can tell them, okay, this is the task name which we have to perform, and put it into this phase, verify phase. Okay, now when you do Maven verify, what it will do? It will first validate, compile, test, package, and then run the check for all these issues. If it find anything, then it will report you. Okay, your sixth phase is install. The command is Maven install. So when you do the install, you have validated your code, you have your bytecode .class file, you have run the test cases, you have .jar file, right? Currently in the target folder. You have also verified that everything is good, there is no static analysis, or if you want, you can add more verify like checksum, signature, anything, right? So verification is also done. Now you want to install. Install means you want to install the package, this .jar file, into the local repository. Now understand this, what is local repository? So in Maven, this is something that this is your system. So let's say me. So this is me. This is my system. Okay, and let's say this is Maven Central. This is public. Okay, this is where so many repositories are available. Okay, so whatever this jar file is created, there is something called local repository here in my system. So local repository lies where? Is in my system. Okay, and this is when this .jar file, I have to deploy it somewhere outside my system. That is known as remote repository. So let's say in this case, Maven Central can be your remote repository. If you are working in a company, then you are within a network where your company has managing your remote repository. So whatever the jar file you will upload, it will get uploaded here, not to the Maven, which is public. It will get away. So this is your remote. But in simple terms, local repository is something in your own system, right? And remote repository is something is outside of your system. I will tell you how you can configure that, whether I should be using this and my company somewhere repository or Maven Central repository. How to do that, I'll tell you. But what it will do, package, what this Maven install will do, it will install the .jar package into the local Maven repository, which is typically located in your user home directory. If you are using a Mac, then it will goes under here, right? So your home, then .m2 folder will get created and repository. So when you will download Maven, right? When you will download Maven, right? Then you will find that this Maven will create this repository, this folder, this path will create. So whenever you do install, so it will deploy it will install this .jar package inside this path. And this path you can configure, you can change it, right? So there is something called settings.xml. In this M2 folder itself. In this M2 folder, there is something called settings.xml file. In the settings.xml file, there is something called local repository. So you can change this path. Then whenever you do Maven install, right? So all your dependencies, all your jar package will goes to that path, not to this path. Okay. So here is like this is generally the structure. So whenever you download the Maven, you will see that M2 folder is also created in your home page. Inside M2, you will find settings.xml, and also you will find a repository folder. Okay, currently you will find only this three: M2, repository folder, and settings.xml. That's all. Now when you will run Maven install, when you run Maven install, what it will do is it will copy all the this jar into this path, and it will follow the path. So it will create like concept and coding, learning springboot, like the proper hierarchy it will make, and then it will ultimately put the snapshot .jar file. So earlier it was present under .target, right, during package. So during Maven install, it will put into this my local repository. This is local repository. And this path I don't want to put into under repository. I want to create some other folder. Might say my folder, and I wanted to put it here. You can change it in the settings.xml. You can change the path of the local repository or give whatever the path you wanted. So the jar file will goes into that one. Okay. So here I am doing Maven install. So it will do first validate, then it will do second compile, then it will run test cases. After running test cases, what it will do? It will do the package, right? It will do the package. After running the package, it will do verify. I think we don't have verify. And after that, it do install. So it do sequence of install, and during install, whatever the jar file was created as part of first this Maven package, it will use that jar file and put it into from target to your local repository path .m2 repository concept and coding. This path it will put it. Okay. And if you want to change it, you can change it in settings.xml. So whenever you download a Maven, this .m2 folder will be created, repository will be created, settings will be created, settings.xml, and you can change it as required. Okay, got it? So now now you have local repository, and then you know that there is something called remote repository. Remote repository could be a company or the Maven Central. So whenever you have to download any dependency, your pom.xml Maven will give preference to local repository. It will check, hey, in the local repository, do I have this dependency or not? If that dependency is not there, then it will goes to remote repository, downloaded it and put it into the local. Now in future when it has to look, then it will look to the remote local, and it will automatically find it because it has already been put in the previous step itself. So you got it? So that's why local repository, you can say that it helps so that we can avoid calling remote repository again and again during dependency resolution also. And the last step here in this is the 7th phase is deploy. The command is Maven deploy. And now you know that when you are doing this Maven deploy command, even if you are running this, all these phases will run also. But what it will do is it will deploy the .jar file to remote repository. Now remote repository could be your company central, or could be Maven public, which is public, it's central. Whichever you will define. I will tell you how you can define it. So in the pom.xml, you have to define something like this. Distribution management. Okay. Distribution management. Inside distribution management, you have to tell repository where it has to deploy your remote repository URL. Okay. So if you see in your company, the POM which we have got, in our POM, the dependency management is not there because it considers that we don't have to deploy. It's just our internal learning purpose. So we don't have to deploy our code to Maven Central or something. So we don't have this. But if you want to deploy, so you have to put the URL where you have to deploy. If you are working in a company, then check your company's POM. You will find that you have provided your company's URL here. So whenever you do Maven deploy, it will goes to your company central somewhere, right? And you, for connecting it, you might need to provide the username password also, right? Because we can't just connect to any URL and upload the jar file there. You have to authenticate yourself. So the username password generally we put into settings.xml. In the settings.xml, there is something called server you can add, and in that the ID is your remote repository ID and the username password you can give. Remote repository username and password. So with this username password, it can connect to your this URL and it will upload the jar there. But there is no default Maven provide. So if you, for our code, here if you see that you won't find any dependency management. You won't find any not dependency, distribution management. You won't find any distribution management and remote repository. If you run the Maven deploy for our current project, right, you will face the below error, build failure. Why? Deployment failure. Repository element was not specified in the POM inside distribution management element. So you have to add it. So now let's say that if you don't want to deploy this jar to your company or something, you want to deploy it to the Maven Central, you can provide the Maven Central URL. And for Maven Central URL, there is no need for username and password because it's public. There is no username password. You can keep it empty. Right? So this is the URL for the Maven Central. If I add this distribution management in our POM, right, and run this Maven deploy, I can deploy it to the Maven Central. Then you also can download that from Maven with this group ID, artifact ID version. This is the coordinate. You can now, if once it goes to the Maven Central, anybody can download this then. You got it? Okay guys, thank you. Bye.